Let's start by discussing the motion of an object like this blue ball here that's moving in a circle, the red circle here, at a constant speed. Now, we can say it's moving at a constant speed, but not constant velocity, because the direction of the velocity is going to be changing the whole time. But the size of the arrow, that's going to be the speed, is going to stay the same throughout the motion. We call this type of motion uniform circular motion. So again here, the speed is constant. However, since the direction is going to continuously change, we know that the velocity is changing, then we know there must be an acceleration. Remember the definition of acceleration? It is change in velocity over time. In this case, the change in velocity is occurring because of a change in direction. A few pointers. For uniform circular motion, the speed is constant, the velocity is not constant because the direction changes, and we need an acceleration. Now, here is a reminder. From what we have learned in the past, if I have an object moving with a velocity in this direction, if the acceleration is in the same direction, then we know that the object speeds up. And we also know, let me choose another color, if an object is moving with a velocity like this, but the acceleration is opposite in direction, so we know it slows down. In other words, for the acceleration to affect the speed, it needs to be opposite if we are slowing down, or parallel if the object is speeding up. Now, in this case, we are not speeding up or slowing down. We are changing the direction, which means that we cannot have an acceleration that's in the same direction as the velocity or that's opposite in direction to the velocity. Neither one of them can accomplish for us a change in direction of the velocity without a change in the speed. So let's look at this. Let's have a couple of definitions. If I have an object moving in a circle, like our blue ball here, what we define as tangent to the circle are these red arrows here. It does not matter the direction they have, but all of these red arrows are tangent to the circle. Okay, so at the point where the ball is, you just draw the arrow parallel to the circle at that point. But since the arrow is a straight line, so you see it coming off the circle a little bit. So it is tangent to the circle. What we define as radial is something perpendicular to the circle, which can be towards the center of the circle, or like this blue arrow or this blue arrow here, parallel to the radius, or away from the center of the circle, like that green arrow. Both the blue and the green arrows, we call them radial. Now, the question is, what is the direction of the velocity of an object if it is going in a circle at a constant speed? Is it the red arrow or the blue arrow? Obviously, here, since it's moving in this direction, the velocity is always along the direction of motion, so the red arrow is going to be the direction of our velocity. Now, what must be the direction of the acceleration if it is going in a circle at a constant speed. What we have decided a few minutes ago, the acceleration cannot be parallel to the velocity, because if it is parallel to the velocity, then the speed is going to increase, and cannot be opposite to the velocity, since that would mean that the speed is going to decrease. So the only other options are for it to be radial, and either radially outward like the green arrow, or radially inward like the blue arrow. And the question is, which one of these? Okay, now if you examine what's happening for an object, in this case it's going in the counterclockwise direction, you notice this is v1, velocity at one instant. A little later, this is the velocity v2. As you notice, one arrow is pointing this way, then the next arrow is pointing like this one here. I'm redrawing it here. It's pointing this way. So the acceleration, to try to change the velocity from this initial direction to this new direction, remember acceleration, whenever you think of acceleration, you need to think of a force. Then this would be the more correct possibility, since it's making it bend towards the center of the circle. In other words, for an object moving at a constant speed in a curved path, the acceleration is going to point radially inwards, like this blue arrow here. I'm labeling it as a sub r with an arrow on top of it. We call that acceleration centripetal. Why do we call it centripetal? Because it's pointing towards the center of the circle. Remember, it is responsible for changing only the direction of the velocity. Okay. One bonus that we have, it is equal to v squared over r. So the acceleration that's responsible for just changing the direction of the velocity is given by v squared over r.